Hello, so today we are going to do this problem called implement trie or prefix tree. So what we want is implement a trie with insert, search, and start with. So we get a trie, we can insert April and then search if it's there, so we return true. Search for this one, it's not there, it returns false, and we can search if something starts with some letters. Can insert and then we'll find it again. All input consists of lowercase letters, and all inputs are guaranteed to be non-empty strings. Okay. Okay, so how can we implement something like this? If we didn't have to start with, we could just have a map and then we could just search, right? We could also do that with start with. Just use the map to go over all the keys and see if any of them start with this. But there is a more efficient way, probably. A map would be very easy. We could just initialize it here, insert the word, or actually not maybe a map, just a set. Insert the word here, check search would be O1, add here to the set. But here we'd have to go through the values and check each one of them. So this one would be O1. If we want, the question becomes, how can we optimize start with, because these operations here are all of one. So we could think of an approach where we have nodes, and we could stop when we reach a path from the root to some node for this here. Okay, so let's do the 3-node solution. So first we'll need to define the tree node. So what do we need to have there? Well, we need to have children, right? So for each node, let's just use collections. Let's just make a map of the children, and let's just give by default give it to be tree node, right? Because that's what we always will be initializing, right? So an empty one should be enough. And then here from collections or import collections. And then here to insert, we could just create the root. So it would be something from trie node here. And to insert, well, we probably need to find the node to insert under, right? So we'd say self dot root, and then we'll say C in word, and we'll say current equal to current dot children of C, and then at the end we'll need to mark it as isWord. So here we need to have something that marks it as the end of the word. So end false, and then here we could say current dot end equal to true. And to search a word, we will need to do that, but check also that current end is equal to true. So we'll do something like this. problem here is that it will exist, right? So we would say here, we would say this. So if C not in, you could say return false, right? We didn't find it. Otherwise, do that. Once we are done with the entire word here, so we need to start first from the root. And once we are done here, we need to return whether we reached the end or not. For start with, we need to do something similar here. So if the character is not in the tree here, we need to return false, and we need to do something like this. But if we reach the end here of the word, it means it existed for all of them, so we can return true. Yeah, I think that should be good. Let's try. Let's just give a map, right? False. False is not defined. What is false? Yep. It's prefix. Okay, looks good for this example. Let's try to search some other stuff here. Maybe. Okay, this complicates the setup. Let me just try. So it's wrong here for one of the examples. Looks like it failed here near the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we were searching for which word? 1, 2, 3, 4, 5, 6, 7, 8, 9. When we were searching for apps, it said false for me. It should have said true because app exists. It's part of apps. And we are searching. Okay, so does that mean if let me try this example here. First, keep this here, test with later. but it seems like here if I search for maybe AP, I get a wrong answer. No, I'm getting a right answer, so well, app was already inserted, right? Okay, maybe let's try something else. Put this here. So let's try an example like the beginning here, but let's just pick app apples. So app. Let's first insert these. Insert apple, app, apps, and maybe also, and then search for app. So this would be insert for this, insert for this, insert for that, and then search for this. Okay, yeah, this is a small example where we could see that app here wasn't found because so probably because this search here finds current to be equal to false. But why? Since we should have. Oh, okay. We override the node here. That's why. So only if C not in current dot children that we should add it. Otherwise we'll use the same one. I think that should be it. Okay, that looks like that was the problem. Okay, let's try again. Okay, seems like let's try with just this big example here. Okay, looks good. Let's try to submit. Okay, so that's accepted. Cool. So pretty much it's just a tree with children's being maps and marking the end of words with and equal to true so that we can search for an entire word. And then with this we can traverse to find a prefix for a word. And that's pretty much it for this problem. Yeah, see you on the next one.